Hello everyone, welcome to my YouTube channel. Today we will be learning the difference about AI, machine learning, deep learning versus generative AI. I have kept this language simple so that everybody can understand, even if you are not from the tech background. You use AI almost every day. Filter unwanted emails, unlocks a phone, recognizes objects in photograph. Now it can now even create text, images, music and computer code. But AI, machine learning, deep learning and generative AI are not exactly the same. These are all different terms with different meanings. They are all connected, but each term has a different meaning. In this video, we will understand the difference between using simple visuals and familiar examples. No complicated mathematics, no confusing technical language. So let's start with the bigger picture. What is AI? Look at the largest circle here. This one is artificial intelligence. AI is a broad field of creating machines that perform tasks that normally require human intelligence. The tasks may include understanding a language, recognizing images, making decisions, or solving problems. Inside AI, we have machine learning. This is a set in which a computer has a fixed rule for every possible situation, and we give it examples. The computer studies those examples and learns useful best patterns to solve that example. Deep learning is more advanced type of machine learning. It uses structures called neural networks with many processing layers. These layers help the system understand complex information such as images, speech, videos and language. Generative AI is used to create. Now the fourth term comes up, generative AI. What is it? It can generate text, image, music and write code. The modern generative AI systems are built using deep learning models. So to remember this relation, you should remember it as AI is the broadest field, ML machine learning is the part of AI, deep learning is part of machine learning, and generative AI is the modern application area that actually uses deep learning. Now moving forward, we can see at an example as explained here as spam and normal email examples entering a machine learning model. On the left side we have training examples. On the right side we have the patterns, and based on that we will make predictions. Some emails are clearly marked as spam, as you can check here. They may contain suspicious offers, they promise free prizes, they may include unusual links, they may also use too many capital letters or exclamation or something that is not common or usual. Below them we have marked some emails as normal. One is the project meeting, one is invoice, one is weekend plans, work messages or messages from the friends and families. What kind of emails given to the machine learning model? Just erase that. So both kind of messages are given to the machine learning model. The model does not understand and memorize each and every email, but it searches for the patterns that it gets from those emails, studies the words used in spam emails, studies the repeated phrases, examines suspicious links, compare these patterns with normal images, normal messages. After studying many examples, the model learns what spam usually looks like. Now a new email arrives, but it can combine new email with the patterns it learned during the training, pattern that it had find out. It then makes prediction. The email may be classified as spam or not spam. The basic idea is simple. We provide examples, system learns patterns, and based on those patterns it makes predictions about the new data that is arriving. To understand how a deep learning recognizes an image, we can take a very simple example of this: identifying a dog. Machine learning works very well for this task. Some types of data are extremely complex. One of those complex data types are images. Images contains thousands or even millions of pixels. Nowadays, based on the camera quality, the images are having lot of pixels. Image enters deep neural network. The network contains multiple layers. The early layers begin to detect very simple details such as the patterns, the texture, background, lines of the image, vertical edges, horizontal edges, corners, light and dark regions, and different directions of the lines. These features do not look like a dog yet. Then, in the middle layer, it tries to find out the meaningful information such as circles, rectangle, triangles, semicircle, or other patterns such as other regular shapes. Layers later combine all of this information into recognizable object parts, such as one can become the ear, one can become the dog's eye, one is nose, one is mouth, one is the face overall. Then finally, the output layer combines all of the information. Based on this, the output object is recognized as a dog. Now let's look at the next example, face scan. Face unlock is another familiar example of deep learning. Smartphone camera captures an image of the face in front of it, but the system does not simply look at the face like a human does. It identifies important facial patterns. The dots are the different structures of the face that, as you can see here, in this one, this, this. The connecting lines represents the relationship that is between all those points. This. The system may examine the distance between different facial regions. It may study the overall structure and proportions of the face. The scanning line shows the phone processing the facial information. This one. Oh, sorry, the line is distorted. This line. If the patterns match closely enough, the system recognizes the user. The green check mark shows the match was successful, and then the phone is unlocked. Deep learning is useful here because a face can look slightly different every time. The lighting may change, the camera angle may change, the person may move closer to or farther from the phone. Well-trained model tries to recognize important facial patterns despite these small changes. Now, after understanding the previous examples, we have to understand what is a generative AI. Now, traditional machine learning usually studies information, produces prediction. On the left, we have a prompt. This you might have seen on the give a prompt and get an output kind of thing. It's been marketed as normal. Prompting is the technique that we use in this. Prompt is basically is a instruction given to AI system. The prompt may ask the system to write a paragraph, generate an image, request Python code, or ask for a relaxing song. The same generative AI concept can be used to produce different types of content. First output is text. The system may create paragraph, story, summary, or explanation. The second output is an image. System may create an illustration based on a written description. Third output is a code. System may generate function, script, or programming example. Fourth output is an audio or a music. The system may generate a melody, soundtrack, or a sound pattern. The important word here is generate. The system is not only labeling it into text, image, code, and audio, but it is generating those. However, generated content is not automatically correct. Generated image may contain strange details. Generated code can contain mistakes. Output should always be reviewed by a person. Let's understand the difference between prediction and generation. On the left side, we have prediction. Existing image of cat is given to an AI system. The system analyzes the image, it identifies visual patterns, and it produces the label as cat. The image is already existed, the AI only predicted what is inside it. Now look at the right side, it is generation. The input is not existing picture, but input is a text or a prompt. AI processes the words in the prompt, understands that the requested image should be a cat. It also understands that the cat should look like astronaut. The output is newly generated image of picture of a cat as an astronaut dress. So the prediction answers a question like, what is this? What? Generation responds to instruction like create. Spam detection is mainly prediction, image classification is prediction, face matching is prediction, writing a paragraph from instruction is generation, creating an image from text is generation. You can look at this school analogy. By this I will explain you everything so that you will never forget. The whole school is labeled as AI. Inside the school there are departments called machine learning. Inside the machine learning department there is a classroom called deep learning, and this classroom uses neural network and many layers. It is especially useful for complex information processing. So the creative lab generates the output such as image, text, music or code. So AI is the whole school, machine learning is one department out of it, deep learning is the advanced classroom inside a department, and generative AI is a lab created with the help of deep learning, but it is generating. There are some common misconceptions regarding AI which I'll tell you. AI intelligence, artificial intelligence is generative AI. That is not correct. Generative AI is only one area within the much larger field of AI. Spam filter can use AI without generating anything. Face unlock can use AI without creating new content. Image generation, image recognition can use AI only to identify an object. Another misconception is that machine learning and deep learning are completely separate. Deep learning is actually a type of machine learning. Neural networks are only loosely inspired by biological brains. They are mathematical systems that process informations through connected layers. They do not think, feel or understand the world exactly as humans do. So let's recap quickly. AI is a broad field of making machines perform intelligent tasks. Machine learning is a part of AI that learns patterns from examples and data. Deep learning is a type of machine learning that uses neural networks with many layers. Generative AI uses learned patterns to create new content. ML often predicts, generative creates. This is the simple difference between AI, ML, DL and generative AI. Thank you for watching. Subscribe to my channel. I will be uploading more tech videos like this, simple explanations and basic understanding. Thank you.